Okay, so today we're going to be talking about the concept of moon time. Not the easiest to master, but I think if you break it down into smaller chunks and understand what you're being asked, it's really not too big of a deal. It actually starts with the relationship between the sun and the earth. So the first part you got to understand here is what time it is on the earth. So I'm going to draw a picture of the earth. Now we are looking down at it from above. So the North Pole is here. You're essentially hovering above it. And because we are not a star, we are half lit and half dark all of the time. For you guys in class, I think you should draw this today. Because I think when you go to do the lab later, you're going to be happy that you have a copy of this, because it's going to speed things up and you'll be able to finish the lab much quicker. So in this case here, we have a Earth that's half lit up and half dark, and it's rotating counterclockwise if you are hovering above the North Pole. So the first hurdle here is to understand what time it is on Earth. So if I were to suggest to you some times, let's say I were to say that we're interested in these times. 6 a.m., noon, 6 p.m., and midnight. The first piece of knowledge you have to master is where on the surface of the earth do these times occur. Now this might seem opaque in the beginning, it might seem a little fuzzy, like what? But if you think about this for a second, I think you'll be able to figure it out. For example, noon is one that I like to start with because I know that noon is when the sun is highest in the sky. Well, what makes the sun appear highest in the sky is the fact that we have spun as much towards the sun as we're going to spin. So at 12:01 or 12:02 p.m., we've already started to spin away from the sun, which makes the sun appear to be lower in the sky. So I know that noon is when we are facing the sun as much as we're going to face it. So I'll go ahead and call this noon. And on that, I can infer that midnight's the actual middle of the night. Now, nighttime to us is actually when we're just facing out towards space. Space is dark, it's cold, that's why it feels a little spooky and cold. Nighttime. I think midnight is going to be when you've spun as much into space as you're going to. So I'm going to call this midnight. Because I know the rotation of the earth, I can then fill in my other two times. When we're spinning from midnight towards day, it's all right to go ahead and call this morning and to call this evening. So I have these major times here that I'm concerned with. I'm going to now go ahead and fill in some minor times in 3-hour increments. What I mean is, if this is noon and this is 6 p.m., I might ask myself, well, what might be there? Well, it's halfway in between, and this is a difference of 6 hours here. I'm pretty sure that this is 3 p.m., about the time that you guys are headed home from school. The Earth spun to about here. Similarly here, halfway between 6 p.m. and midnight is 9 p.m. This will be about 3 a.m. And this will be 9 a.m. That's about as tight of divisions as we're going to get for this. This is about all that we need. So once I've mastered time on Earth, I can then start to think about how we can use the moon to tell time. This idea comes from where the moon is positioned. So I'm going to start with one that's, I think, is the easiest. I'm going to draw the moon right here. And think about what moon phases might be. Now you might say, well, I have no idea what that might be, but I did give you this thing to help. Now, notice here the sun is at the bottom, and I put the sun on the side, no problem. Cool thing about this is you can just flip it on its side. So we have a sun, an earth, and a moon. I can see here that this is the full moon. I'm not going to draw the moon phase here. I'm really referring to here, the moon position. So if I want to, I could even like color this in if I want. Now mind you, this is not a quarter moon. Here's our quarter moons, but you'll see here that just like the Earth, the moon is always half lit and half dark because it's not a star, but it's near a star. It's near the sun. So midnight for that moon here, and I know that this moon is the full moon. While I'm at it, I think I'm just going to color in all of my major moons here. I know I'm coloring them all half light and half dark. I'm drawing the actual appearance of the moon in space, not what we see. I'll draw that in a second. I'm not drawing what we see. I'm drawing what it looks like if you're floating out in space. Now I'd like to return to this full moon for a second. Well, before I do, because I've already done this, I'm just going to go ahead and label the names of the moons that I drew. And if you're like, well, I don't know where that information is, again, it's housed right here. It's also in your notes, that note packet I gave you guys, but I find it's easier to grab it off of one sheet instead of paging through all those notes. Okay, so believe it or not, yes.
What is that sign?
Which one? Waning. Yeah, waning. If you can't see it, I would say to pull out this sheet and then tilt it on its side because this is all the names of them right here. Oh, okay. Well, I guess I'll give you mine. Here you go. You're welcome. I have extras. I just have to dig them out there. So guys, believe it or not, we've actually covered two big pieces of information. Time on Earth and then position of the moon with corresponding names of the moon phases, which is huge. Now, here's the refreshing thing about the moon. Unlike the sun, which has varied times of day that it's out for, like right now it stays dark most of the day, because we're in November. And then in the summertime it's out for 15 hours. In December it's out for 8 hours. On the equinox it's out for 12 hours. The moon is always out for 12 hours a night, which is going to make this helpful. So it's 6 hours for it to rise up to the highest point in the sky. Then it's 6 hours for it to set. So with that in mind, I want to return to this full moon here. If I want to know when the full moon is the highest in the sky, it's the same thing as saying when have we spun to where that full moon is. And you might say, what time would that be? Well, if I look and see when we've spun to where the full moon is actually located, I can go ahead and say it's midnight. Wonderful. What time did this moon rise? Well, I told you it's 6 hours before it reaches its highest point. So midnight's 12 a.m. If I go back 6 hours, it rose at 6 p.m. If I want to know what time it's going to set, I go forward 6 hours, and it's going to set at 6 a.m. Now, this might seem like a crazy concept, but it's really not, because when we consider the sun, it makes perfect sense. If I want to know when the sun is going to be highest in the sky, aka when did we spend the most towards the sun, we already said that was noon. If I want to know in this diagram here, what time did the sun rise, it looks like it rose about 6 a.m. If I don't want to know what time it set, it looks like it sets about 6 p.m. So we're pretty familiar with it when it's the sun, but when it's the moon, we're like, whoa, really? Yes. But the thing is, the moon is moving around us, and we're moving around the sun. So the sun-moon thing is a little bit different, but watch, the same concept works. Let's go to a different moon, the waning gibbous. If I want to know when this thing is going to be the highest in the sky, aka when have we spun the most toward the waning gibbous, it's not going to be midnight anymore. You can see that that's not where it's going to appear highest in the sky. But what time might it be? Mason? 3 a.m. Very good. Yeah, it's going to be 3 a.m. So 3 a.m., highest in the sky. And if I want to know what time it rose, I'm just going to count back 6 hours. It rose at 9 p.m. And if I'm real curious what time it's going to set, it's going to set at 9 a.m. And you can do this for every single moon. The third quarter, highest in the sky at 6 a.m. If I want to know what time it rose, I count back 6 hours. The sky rises at midnight. What time does he set? He sets at noon. This also explains if you've ever wondered why we have some moons that are out during the daytime. Some moons just haven't set yet, or some moons are just rising in the daytime. And some moons are actually at their peak, like these crescent moons, during the day. So we're going to take it a step further in just a second so you can see what the problems are going to look like. But one thing I did want to show you guys was, I'll post that up. The simulator here. The last piece of this simulator that we haven't really talked about too much was this one that's down here. So this is essentially going to show that same thing. The moon is a gray circle, the sun is a yellow circle, and you'll see that depending on the moon phase, the sunrise and the moonrise, sunset and moonset, are going to be different in time. Like some periods of the month, they're very, very close together, and then other times they're very far apart. By the time you get to like a full moon phase, it's the sense that the sun is rising, the moon is setting, and the moon is rising and the sun is setting. And then they're going to start to tighten up again in time. So I'm going to fast forward this just to show you. So this is about as far apart as they're going to get. That's why we see so much of the full moon and the gibbuses. They probably look very familiar to you as moon phases because they're out a lot of the night. If you look here, this is a waning gibbous. It's a lot of the night sky to himself before the sun comes out. Versus crescent moons, you might catch them in the morning or right in the evening, but they're usually rising or setting right before the sun is going to interfere with them. So that explains why we have some moons out during the day and some moons out are primarily at nighttime. Okay. So the third level of this, the third tier, is to say this. You now understand that it's 6 hours up and 6 hours down. The next place we take it to is directions. So if I want to see something rise in the northern hemisphere, what direction might I look? Yeah, I heard someone say east. Very good. If I want to see something set, I might look west. Very good. So how we like to present these things is give you a moon phase, and then give you, this is just the ground here, and then give you a direction, east, and then ask you what time is it? So the moon phase that I'm looking for, oh no, they all look like this. What am I going to do? Well, again, that's where that little sheet is helpful. But on my sheet, just to really complete it, what I would like to do is actually draw the moon phases as we see them. Okay, so one more on the outside here. This is where that moon phase actually looks like. But I know a waning crescent does not look that way. A waning crescent looks like this. So I'm drawing now what we see. A new moon. A waxing crescent has the little fingernail on this side. First quarter. Waxing gibbous. Full. and a waning gibbous. Okay. Now that you've constructed this too, by the way, if you